Hello, in this session, I want to explain what AWS Global Infrastructure is and why it's important to understand when building on AWS. When you hear the word infrastructure, it typically means things like roads, bridges, and electrical grids. These components work together to provide a service-like ability to travel. Likewise, AWS Global Infrastructure is made up of things like computers, data centers, and high-speed network to provide a cloud computing service. So let's start with AWS data centers. These are large buildings that contain lots of computer equipment. It needs things like electric power, cooling system, and high-speed internet connections to operate. They also need to be physically secured and make sure only authorized people are allowed in. You can see how building such a data center would take a long time and be very expensive. This is why you may choose to use AWS rather than build your own data center. Over the years, AWS built many data centers around the world, but they are not randomly located. Instead, each data center is purposely located within a cluster called availability zones. So one availability zone consists of one or more data centers. Each AZ is designed to be self-sufficient with its own power supply and redundant internet connections. Similar to data centers, the availability zones are not randomly located around the world. Instead, each availability zone is located within a cluster called a region. So one region contains typically 3 or more availability zones. So the idea here is that each AZ is far enough apart that in the event of natural disaster like earthquake, it won't wipe out all of the AZs within a region. However, the AZs are close enough so any computer-to-computer communication across AZ is really fast, typically within a single-digit millisecond. This lag between computers is known as latency. These regions are built to be isolated from each other such that even if an entire region goes down, all other regions will still operate normally. Finally, the regions are grouped into a cluster known as partition that provides different levels of service. Examples of partition include commercial, GovCloud, and China. So AWS data centers are grouped into availability zones, and availability zones are grouped into regions, and regions are grouped into partitions. AWS computers are sometimes placed in data centers that are not wholly owned and operated by AWS. For example, some AWS computers are housed inside a telecommunication data center like Verizon. This is called Wavelength Zones. You may want to use this for mobile games that need fast connection via 5G network. Another example is a local zone, where AWS computers are placed inside a data center near a populated place like a large city. AWS also places computers in a data center known as point of presence or POP. These computers store things like images and videos that are viewed frequently. For example, let's say you created a cat video that's gone viral around the world. If you store this video in one data center, it may be quick to download for people nearby, but would be slow for the rest of the world. If instead you use POP around the world, your video will be available for quick download closer to your audience. This concept of distributing copies of your content is also known as Content Distribution Network, or CDN. Lastly, you can have AWS computers inside your own data centers or even out in the field. These are known as AWS Outpost and AWS Snow. Another important component of AWS Global Infrastructure is its network. AWS has built high-speed connections between regions and availability zones that allow low latency and private communication. AWS has also locations where you can establish high-speed connection between your data center and AWS, known as Direct Connect. So all of these components make up the AWS Global Infrastructure. On top of this physical infrastructure, AWS provides software like database and GenAI. This combination of physical infrastructure and software as a service has many names like cloud computing and cloud service provider. The good news is that AWS is open to the public and you can access it through the internet. So I hope this gives you some idea what AWS Global Infrastructure is and why it's important to understand when building on AWS. In this session, I'm going to discuss 5 things to consider when deciding on AWS Global Infrastructure. First thing to consider is your compliance requirements. Depending on the country and industry, your application needs to comply with certain laws and regulations. Based on this, you can select which AWS partition is right for you. Note that just because you build on these partitions does not mean your application is automatically compliant. You still have to do your part to be fully compliant. This is called the shared responsibility model. Once you select a partition, the next step is to select a region. Some partitions like GovCloud only has few regions, but the commercial partition has many regions around the world. So how do you choose which region to use? This is where you should consider latency. In other words, you want to select a region that is closest to your users to provide the best experience. If you're considering using local zones or wavelength zones to further reduce the latency, just keep in mind that these are not available in every region. Another important consideration when selecting a region is your compliance requirements, such as data residency requirement. Next consideration is high availability. In other words, what happens if something fails in AWS? In the words of Werner Vogel, the CTO of AWS, everything fails all the time. One of the key concepts when building on AWS is to distribute parts of your application across multiple availability zones or even copies across multiple regions. So if one AZ goes down or a region has a problem, your application can still function. Keep in mind that certain regions have a special purpose when it comes to global services like identity and access management. For example, in the commercial partition, the US East 1 region is responsible for the administrative functions like creating a user or editing permissions. This means that if the US East 1 region goes down, your application in other regions will continue to function in terms of IAM, but you won't be able to create new users or edit permissions in the IAM service. This concept is called control plane versus data plane and should be considered when designing a high availability architecture. When deciding on high availability, a good place to start is to understand your RTO and RPO requirements, as well as your business continuity and disaster recovery plan. This can help you decide if your application should operate in a single availability zone, multiple availability zones, or even multiple regions. Next thing to consider is service availability. AWS has over 200 services such as compute, storage, and database. However, not all services are available uniformly. For example, a GovCloud region does not have all the services that are available in a commercial region. Even within a partition, not all regions have parity. For example, a commercial region of US East 1 usually has all the services including the latest releases, while other regions lag. Even within a region, wavelength zones, local zones, and outposts don't have all the services that are in the availability zones. Depending on your use case, you may also need to consider the scarcity of services. For example, let's say you need the latest GPU-based computers for your AI application. Even though that specific instance type is available in your region, you may not be able to get one due to the scarcity across different regions. The last but not least consideration when building on AWS Global Infrastructure is cost. Simply, AWS cost is not the same across partitions and regions. For the same service, some regions cost more than others. Another factor is the data transfer cost. Examples include data going out to the internet, across regions, or even across availability zones. The data transfer rate depends on the region and service. So if you decide on multi-AZ or multi-region to achieve high availability, then consider the cost implications of not only the services, but also the data transfer. There's a lot to think about when building on AWS, but when it comes to AWS Global Infrastructure, consider these factors that we discussed. I'll leave a link below where you can find more information about AWS Global Infrastructure.